Welcome to this explainer. So, you know that familiar knot of anxiety you get in your stomach when you're staring down abstract math rules? Yeah, we've all been there. But today, we're totally replacing that anxiety with everyday common sense. We're breaking out of that rigid textbook world of rote memorization and stepping out into the real world, a world where numbers actually represent physical things you can see, touch, and just intuitively get. Trust me, it's way simpler than it looks. Let's get right into it. I mean, look at this. This quote right here perfectly captures a shared universal trauma. Minus times minus results in a plus. The reason for this we need not discuss. Sound familiar? For generations, this old mnemonic has literally been hammered into our heads. But think about what it's actually doing. It's demanding that we memorize a rule without any grammatical or logical sense. And memorizing rules blindly, without understanding the why behind them, well, that is exactly the villain we're taking down today. We don't want to just execute procedures like calculators. We want to actually think.
Okay, consider this for a second. -7 minus -4. If you ask an adult who doesn't do math for a living, they usually get it wrong. But if you ask a 12-year-old, hey, what does 7 negatives minus 4 negatives equal? They almost always get it right. Crazy, right? Why is that? It's because in that first phrase, the syntactic structure is totally broken. -7 minus -4 is basically adjective, adjective, verb, adjective, adjective. There's no noun. The whole equation just loses its meaning because there are zero physical objects to anchor it. We desperately need those physical anchors. So let's dive into phase 2 of introducing integers, building real-world intuition. We are completely avoiding the memorization of rules here. Just picture a tall building with an elevator. The floors above ground, those are our positive integers. The ground floor is just 0. And the basement levels below ground, well, those are our negative integers. Suddenly, -3 isn't some weird abstract void. It literally just means you're 3 floors below ground level. Negative numbers are simply locations below 0. It just makes sense. Here's another perfect real-world anchor, temperature. Let's say today it's exactly 0 degrees outside. Tomorrow, it gets colder by 3 degrees. And the day after that, it drops another 5 degrees. Where are we at? We're at -8 degrees. You see, kids intuitively understand negative integers through temperature because a winter day dropping below freezing is something you can physically feel. The math on the page, it's just a representation of the reality you experience the second you step outside without a coat. So, the absolutely crucial point here is how we reframe our language. Think about that intimidating math jargon for a second. Add a negative number. Your brain kind of short circuits, right? I mean, how on earth do you add something that isn't even there? Instead, try reframing it as add more debt. Imagine you owe a friend $5, and then you borrow 3 more. You didn't receive money, you received more debt. Adding a negative is brilliantly logical when you realize it just means adding more onto what you already owe.
Right, now let's tackle subtracting a negative. This is the one that always trips people up. Let's say you owe $10. You're in a negative state. Now, someone kindly forgives $4 of your debt. What just happened? They subtracted a negative from your life. They removed some of that debt. Is your situation better or worse? It's better, right? Removing something bad naturally leads to a positive outcome. Sure, you still owe a bit of money, but your overall net worth just moved in a positive direction. See? It's not magic, it's literally just the logic of a bank account. But now, we have arrived at the absolute hardest concept in integer arithmetic, the final boss of middle school math. Why on earth does a negative times a negative equal a positive? Like, how can we possibly make sense of multiplying 2 negatives without just completely giving up and surrendering to a rulebook? You can't multiply a debt by a debt. That makes absolutely zero financial sense. If I multiply my credit card debt by my mortgage debt, I definitely don't suddenly become rich. So clearly, we need a better metaphor. Stick with me here on this step-by-step time machine metaphor. First, imagine positive means moving forward in time and negative means moving backward. Got it? Now, what does a multiplier actually do? Well, a positive multiplier says, hey, do this action. But a negative multiplier means reverse the action. So if you're told to jump backward, but then you get hit with a negative multiplier, you have to reverse your backward jump. And what happens when you play a backward action in reverse? You move forward. Backward of backward becomes forward. Let's really solidify this idea. We need to stop thinking of the minus sign as a bad quantity. Just treat the negative sign as a simple instruction, kind of like a movie director shouting out commands. The first sign tells you whether to let the tape play normally or rewind it in reverse. The second sign tells you the physical direction the actors are actually walking. So if the actors are walking backward on film, that's a negative direction, and the director hits rewind, that's a negative action, the audience watching the screen sees the actors moving forward. It's wild, but it works perfectly.
And this brings us to a brilliant historical illustration of exactly what we're talking about. This is the Brahmaguptan plane, inspired by the 7th century Indian astronomer Brahmagupta. He documented laws of science not for abstract rules, but for real physical quantities. On this plane, the horizontal axis is your noun, your fortune, or your debt. The vertical axis is your verb, your instruction to either add to zero or subtract from zero. It visually proves how adding or subtracting quantities maps perfectly onto 4 geometric quadrants. It literally brings the noun and the verb together in one place. So instead of memorizing abstract signs, you can organically discover the results just through physical movement. Take a look at this. Plus times plus, you do a positive action, the result is positive. Minus times minus, you reverse a negative action, the result is positive. It just makes so much sense. We aren't really doing math, we're just describing physical reality. Think about it for a second. Doesn't this feel infinitely more satisfying than just blindly chanting 2 minuses make a plus? And all of this builds into the much broader purpose of how we learn today. The goal of modern mathematics is not to turn you into a human calculator. I mean, machines do that way faster and better than we ever could anyway. The real goal is number sense. It's about fluidity. It's about flexibility with numbers. It's about looking at a problem, recognizing the real-world patterns, and navigating them intuitively. When we build intuition using everyday things like elevators, temperatures, and time machines, we are building deep, truly flexible number sense. Which brings us to a pretty profound realization. When math connects to reality, it stops being this weird abstract magic and just becomes common sense. Mathematics isn't some secret language invented just to confuse you. It is fundamentally a way of thinking about the world. It's the language of the universe translated into quantities and actions. When you empower yourself to see math in your daily physical environment, whether it's in your bank account, in the winter frost, or riding the elevator, you become a master of it. So I want to leave you with this final provocative thought. If a concept as notoriously confusing as multiplying negative numbers can be completely unlocked just by changing how we look at it, if we stop treating mathematics like a rigid set of rules, what other impossible subjects could we finally understand? If we demand common sense and physical reality from everything we learn, the whole world opens up. Thank you so much for joining me on this explainer. Keep questioning the rules and keep finding the logic in the world around you.